it would have been better to put this talk earlier in the conference, because you've heard about OpenTelemetry hinted to in many other talks. So apologies for that. But maybe now it will connect the dots in many other aspects. So OpenTelemetry 101. I'm going to talk about what OpenTelemetry project is and why we need that. Then I'll go over the different components that comprise this project. Then where this project currently stands, whether it's GA, what can we do with it, and lastly, how to get started with it. As I was kindly introduced, my name is Dotan Horovits. I'm the principal developer advocate at Logs.io. You heard the name earlier today. Logs.io provides a cloud-native observability platform that's based on popular open source tools, such as names that you've heard earlier today in different talks: Jaeger, Prometheus, OpenTelemetry, of course, OpenSearch, and others. I'm an advocate of open source and communities, as you heard, specifically also the CNCF. I co-organize the local CNCF chapter in Tel Aviv, so if you're around, do pay us a visit. And I also have the podcast, Open Observability Talks. So if you are interested in open source, DevOps, observability, do check it out. And with that, let's talk about observability. And I know you heard about observability in the previous talk and some others, but I want to start there to understand what OpenTelemetry comes to solve. So as we know, observability is the traditional definition is the ability to understand the state of our system based on the telemetry that it emits. And the vision talks about bringing unified observability across different signals. Most people talk about metrics, traces, and logs, but as mentioned earlier, it's definitely not just that. Things such as continuous profiling, events, exceptions, and others could definitely be significant signals. But also, very importantly, also from different sources. So think about different open source tools that you have in your framework, different cloud services, and even within your application, the front end, the back end, whatnot. Fusing all of these together to gain insight into our system, that's the vision for unified observability. The reality, however, is much more fragmented. And the reason is that we simply, most of us use many, many tools, different tools for our observability. I want to make a very quick raise of hands. How many people use between, let's say, 1 to 5 different tools for observability? Raise your hands. Okay. How many people use 5 to 10 different tools, observability? Okay. How many more than 10? Well, you might figure out that you're not even aware and you have more than that, but never mind. A very recent micro-survey by the CNCF showed that 25%, 1 out of 4, use between 10 to 20 different tools for their observability. 10 to 20 different tools. And each tool and each vendor has its own API and SDK to instrument the application so that you actually get logs, metrics, traces emitted, and then their own agent, daemon, collector to collect that, to aggregate, process, sample, whatnot, and then their own transport protocol, data model to send it to the backend. And all of that is not only a headache operationally to run so many different tools, it also is a problem for observability because different tools create silos. And then being able to ask and answer questions across these different signals, across these different sources, across different programming languages, across correlate the data becomes very, very difficult, if not impossible. So that's in essence what OpenTelemetry project comes to solve. OpenTelemetry, or OTEL as its nickname, so if I say OTEL, do mind, is essentially a framework for generating and capturing telemetry data from our systems across traces, metrics, and logs. So essentially one framework to rule them all, if you like. And it's an open source under the CNCF. In fact, it's a merge of Open Tracing and Open Census, if you're familiar with these projects. And by the way, if you are familiar and you still use them, that's the time to migrate. They're already deprecated. And the most important thing is that it's widely adopted by all the major vendors in the industry, whether the cloud providers, the monitoring and observability solutions, and APM vendors, all of them aligned with that as their standard way of collecting the telemetry, just like you saw, for example, with Jaeger before. And also, they started contributing and being active in the project. This is a recent survey from the CNCF, and you can see over the past 3 years or so, the involvement of different vendors in the project. You see all the big names here. You see Amazon, Microsoft, Google. On the cloud front, you see all the APM and the monitoring and observability like Dynatrace and Splunk and Datadog and whatnot. So they're getting active. They're getting involved, and that's important. And in general, this is a highly, highly active project. In fact, it's the second most active project in the CNCF today, second only to Kubernetes itself. So and that, by the way, is taken from the CNCF dev stats. So you can go there, you can open this Grafana dashboard and check it out yourself. But it's pretty consistent. And that's what you need, and that's why I'm so happy about that, because that's what you need to get a project to become a de facto standard. You need this adoption, you need to converge the industry and the players together. And interestingly enough, note that I think we are all engineers, so less of our bread and butter, but even Gartner, the analyst firm, started covering OpenTelemetry as part of its, as you can see here, the hype cycle for emerging technologies. I don't know if you can see it's at the bottom, so apologies about that. But for those who are familiar with the hype cycle of Gartner, you can see that this is, the OpenTelemetry is at the beginning, the innovation trigger phase, with Gartner expecting it to reach the plateau, which is, let's say, the maturity phase, within 2 to 5 years. So again, that's usually for more for the business people than us engineers, but very, very interesting that Gartner started covering OpenTelemetry. So I hope that I convinced you that OpenTelemetry is interesting and it's set to become a standard and that you want to hear more. And with that, let's go deeper into what exactly OpenTelemetry provides us. So as you can see here, OpenTelemetry provides us with a unified set of vendor-agnostic APIs, SDKs, and tools for generating telemetry data, logs, metrics, and traces from our applications. That's the bluish part on the left-hand side. And then it provides a standard way for collecting the telemetry data from our system. That's the orange side. And then a standard way of exporting that telemetry data and sending it to whichever backend of choice. OpenTelemetry doesn't have any backend as part of the project, and it doesn't have any stake in the backend. So it's your choice, and lots, as you can see, you'll see soon, many are supported. So that's in a nutshell, but don't worry, I'm going to go over that one by one and provide more details on each component. But before going into the components, I want to say a word about OpenTelemetry Specification. That is not a component per se, but it governs all the rest of the components in a way. It describes the cross-language requirements and specifications that all the OpenTelemetry implementations should adhere to. So in essence, it provides the API specification, the SDK spec, and the data spec, things such as semantic conventions and so on, for logs, metrics, and traces. And why is that important? That comes to answer exactly the pain we talked about before, that the fragmentation that each programming language and each vendor and each tool and each environment has its own. Now you have one unified standard specification. And also, since it aggregates logs, traces, and metrics, it enables the correlation of the different signal types, the different data types. So that's about OpenTelemetry specification. And the next component is the OTL client libraries, where most people start their journey. The client, from OpenTelemetry perspective, you get one API and one SDK per language, for instrumenting your application in a manual instrumentation format. You also get, so you get one for Java, one for .NET, and so on, all of which, of course, adhere to the API spec and the SDK spec we talked about before. And then you also get things such as, for different programming languages, a auto-instrumentation agent that can actually instrument without you needing to modify your code. So manual instrumentation requires you to put some lines of code, like we do traditional logging. We add the line to output the log. So auto-instrumentation saves us that need or makes it much less of a change of code. Then you get all sorts of integrations with frameworks for different programming language. So, so that if you write Java with Spring Boot, or you write Node.js with Happy or Express, you have integrations to get telemetry from these frameworks. So you get, essentially, OpenTelemetry offers you everything from fully manual to fully automatic and anything in between. That's the mission statement. So that's the client libraries. The next component I'd like to talk about is the OpenTelemetry Collector. And the collector can collect data from the OpenTelemetry SDKs we talked about just now. But it can also collect data from many other parts of your system. You have Kafka, you have Redis, you have Elasticsearch. No matter what, you can get from these components as well. Get that, process that, and then send it to whichever backend you want for analytics. That's in essence. And it's built like a typical data processing pipeline. So you have receivers in multiple formats. I don't know, it's a bit low, so I hope that you can see the lower half. Receivers in multiple formats. You want to ingest Jaeger receivers, then just Jaeger tracing, you just plug in the Jaeger receiver. You want to have Prometheus metrics, you plug in the Prometheus receiver, and so on. Then you have a list of different processes to do things such as filter, batch, modify, aggregate, sample, whatever. You can also chain different processes to get more elaborate logic. And then, depending on your backend, you plug in the relevant exporter. So you want to send it to AWS ECS, you want to send it to Google PubSub, you want to send it to, I don't know, Dynatrace, Logs.io, whatever. You just plug in the relevant receiver. So that's the collector. And the last component that I would like to talk about is the OpenTelemetry protocol, OTLP. It is essentially a general purpose telemetry data delivery protocol. So you can use it to transmit between the SDK and the collector. You can use it between the collector and your backend analytics tool. You can use it between intermediary nodes, two different collectors or whatnot. It's really a general purpose protocol. It's built, again, I'm sorry that it's a bit maybe low for some of you, but it's built on top of gRPC and HTTP 1.1. In terms of the encoding, it supports binary protobuf. It does actually work to support also JSON. And very importantly, it's built on the data specification we talked about before. So there is one unified way to represent logs, metrics, and traces on top of OTLP. Now, I want to say one important note. OpenTelemetry does not mandate you to use OTLP. As we saw before, the collector supports many protocols for receivers, for exporters. The SDK itself can also export in many formats. So you're not bound to using OTLP as a protocol. However, as a project, as a holistic project that aims to provide a holistic framework for observability, OpenTelemetry provides also this unified protocol that also enables, remember that, the ability to correlate different types of data when it's on top of the same payload, the same protocol. And by the way, the same goes to OpenTelemetry in general. You can use the collector without SDK, you can use the SDK without the collector. So it's a loosely coupled, yet a holistic framework for generating and collecting telemetry data from your system. That's what we aim for with OpenTelemetry project. So now that we understand where the main components of the project, let's talk about where the project stands. And question to the audience, is OpenTelemetry GA? What's the answer? Who thinks yes? Raise your hand. Who thinks no? No one. Who thinks it depends? You're a very wise audience. So the answer is it depends. All the ones who are right can come after the talk, and I'll give you stickers of OpenTelemetry as a gratitude, or of the may the open source be with you. You can choose. But let's understand why it depends. It depends because OpenTelemetry is essentially an aggregate of multiple groups, each one working on a different piece of this humongous endeavor, okay? And each group and each such project has its own phase of maturity, its own life cycle of that specific project, which means that different components of that could be in different stages of their maturity life cycle. So think about the group in charge of creating the Java SDK, another group for the Node.js SDK, another group for the logging specification, another group for the Go auto instrumentation agent, and so on and so forth. It's really complex. And when I talk about the level of maturity or the life cycle, in CNCF's terms and standards, the life cycle goes, if you can see here at the bottom, from draft to experimental to stable, then to deprecated. So that's the life cycle, but to translate it to common terms that we all use, I would say that stable is GA, generally available, what you would be looking for to run this in production, with guarantees, long-term support, and backwards compatibility, and so on. Experimental would be the point where you can start POCing, testing the technology, experimenting with it, and getting familiar with that. So that's just to align the terms. And okay, so you'll say, Dotan, we understand that it's complex, but still, what's the state of the project? And I'd like to answer that based on the signal types that we talked about. And the first signal that I would like to talk about is traces, the most mature signal of all, that's already generally available since last year. And that means that the API, the SDK, the protocol are stable. There are lots of client libraries in multiple languages, as you can see here, that are already version 1.0 or above. 1.0 meaning that the tracing implementation is complete. And it keeps on advancing in such a rate that maybe even this list is already out of date and there are more. So really moving fast. And most importantly, as we mentioned, for running it in production, what you'd be looking for, long-term support, backwards compatibility, and dependency isolation, things like that. So that's about distributed tracing. Next up is metrics, that is already in release candidate. In fact, we announced the release candidate at KubeCon Europe back in May, which means that to most things and purposes, the projects are stable, the API, the SDK, the protocol are stable. We have client libraries in quite a few languages that are already themselves RC, that are already stable, and working on more and more languages. And very importantly, I think it was mentioned also earlier by Julien, if I'm not mistaken, or others, very good integration with Prometheus. Part of the advantages of having both of them under the same roof of the CNCF, there was very, very productive collaboration that allowed OpenTelemetry to support Prometheus, and as you heard maybe on the previous talk, also Prometheus to support OpenTelemetry. So that's very, very important for metrics. And the least advanced is logs, that is still experimental. Although some pieces are more advanced, as you can see, the protocol is already stable. The APIs and SDKs are still experimental. The specification for API and SDK. And generally, just to say a word maybe about logging, that's the trickiest, just because it's the most long-standing signal. Everyone has logs, right? And we can't just come as an OpenTelemetry project and say, okay, we know how to do logging best, throw everything you have, start from scratch. It doesn't work like that. So the first focus of the community was to support existing logging frameworks and conventions and the flat files, textual-based files, to the best we can. Work, for example, on log appenders in development in many languages. some major contributions to the collector that supported many formats for logging. That's the first phase. However, as I mentioned, as OpenTelemetry's mission statement, to align that, we do look into actually providing a specification and a standard for logging as well. And this work has started already, obviously starting with the specification phase. We need to understand what a log should look like, with the aim of getting well-structured, strictly typed, machine-readable format for logs. So no longer the flat files, text-based, that you need the full text indexing to understand what goes on there. So that's where we're aiming at with specification. Again, work has started. There is some discussions also with the ECS community, Elastic Common Schema. We're trying to figure out, I had an interesting discussion with the guys from Elastic here at the conference to try and understand where it stands, but two different initiatives that look at the problem of how to formalize and structure logs. Very interesting. So that's about the signals. I want to give a few, very briefly, a few other updates. First of all, I wrote a blog post after KubeCon. You have the link here below. It was posted on the CNCF blog with updates, so you're welcome to see there. I just want to tease the mind. I think that earlier talks also touched some of these, where we're heading with that. So first of all, going beyond logs, metrics, and traces, no. 3 pillars of observability is misleading. There are more signals, and the most focused one now is the effort around continuous profiling, looking at how to bake that into OpenTelemetry. Very interesting discussion started at KubeCon Europe, then a month afterwards at OTL Day, and then a SIG, a special interest group, was formed around this effort. Another effort around client-side instrumentation, adding real-time, real user monitoring support. So if you have web-based or native mobile app type of client-side application, how do you collect telemetry, logs, metrics, traces out of that? And that's true, you have JavaScript SDKs, you can start doing things, but in terms of the specification, you want to make the specification suitable for client-side interactions, to have a representation of things such as the session ID and the page views and things like that that don't exist in the backend. So another very interesting working group that was formed to look into that. eBPF, I don't know if, who knows what eBPF is? In a show of hands? Not many. So I'll say very briefly, it's a technology for the ability to inject pieces of code in the kernel level to run in a sandboxed environment, but in the kernel level. So one layer underneath the programming languages. It can be done for packet processing. That's the original context of BPF, but then the extended BPF went far beyond packet processing into security and also observability use cases. And the benefit essentially is that now we need instrumentation depending on the programming language. So in Java, for instance, the JVM allows us all sorts of things that we can do in the JVM phase of the bytecode. So we do that. In Go, we don't have that. So we need to do all sorts of other sticks and tricks. And in other languages, so it's really dependent on what the languages offer in terms of hooks and modifications to the code and so on. But if we can go one level below and inject that observability instrumentation in the kernel level, we can do that actually independently of the language to a large extent. So that's the potential. I actually wrote a blog post about eBPF and its power for potential for observability, so highly recommended. But lots of discussions now in the OpenTelemetry group around that. By the way, for Go language, there's already an auto-instrumentation library, SDK, that uses eBPF for auto-instrumenting Go. I don't know if you know, but Go is very problematic with tweaking and tuning. It's self-included, and it doesn't let anything in. So it was a perfect use case, but the use case that succeeded, and maybe we'll see that at Rust and other compiled languages. So eBPF, a lot of focus on productizing and making easy operation of OpenTelemetry components. So we already have an operator for OpenTelemetry. You can already install using a Kubernetes operator, but going beyond the deployment, How can we collect metrics out of the OpenTelemetry Collector and monitor it to make sure that it's up and running? How can we modify the configuration post-deployment? All of these, a lot of effort that has been looked into in this context. There's actually a group formed around OPAMP, which is Open Agent Management Protocol. So very interesting. OpenTelemetry demo is already in GA. So if you are looking to experiment, now you have a formal demo. It was announced actually just a week or so ago. Very exciting. You have all the flow of running complete end-to-end distributed system instrumented in OpenTelemetry with traces and metrics. So check it out. The port for OpenTelemetry is now officially part of the Internet Association. So lots of other updates that I haven't encountered. I just wanted you to understand very, very active project on many fronts, not just the signals and the data, also in operationalizing it and more. So definitely check it out. And now I would like to say a word about how to get started with OpenTelemetry, because it can get very confusing with all these different components and SDKs and APIs and so on. How do you get started simply? And my tip when I've been asked this is start with knowing your stack. And here are 4 basic questions that are a good place to start and asking. First, which programming languages do you use in your system, especially if you're a polyglot organization, that you have the front end and the back end and others. That will help you determine the APIs and the SDKs and maybe auto-instrumentation libraries, the client libraries that you will need in order to instrument your application. Better yet, even ask which frameworks you use, because also integration with the programming frameworks. Next, which signals? What are you going to collect? Logs, metrics, traces, and also in which protocol. Very important, especially if you're a brownfield project and you have some pieces already there emitting, I don't know, traces in a Zipkin format or something like that. You want to adhere to that. And also from which sources. Because again, you may have a Kafka cluster that you need to monitor, Redis, an HTTPD server or whatnot. You want to make sure that you have the right receivers to ingest this telemetry data. And then lastly, which analytics tools you're going to send it to. You want to send the traces to Jaeger, you want to send it, I don't know, logs to OpenSearch, to Prometheus, or it can be different tools. It could be one tool to aggregate several, but this will determine the exporters that you would use from the OpenTelemetry Collector. Once you figure out which components you need, then you can go check the status of these specific components and follow the respective guides. There's a very useful page that we've added as part of OpenTelemetry website, opentelemetry.io/status, that gives a fairly good high-level status overview. Other resources that you'll find useful, obviously the docs. There is a registry that helps you, in essence, navigate through the massive GitHub repo of OpenTelemetry. So instead of just starting to lose your way around GitHub, go to the registry and search, I don't know, .NET auto-instrumentation, and it will take you to the relevant places. I also want to invite all of you to check out the guide to OpenTelemetry that I wrote. It gives a good beginner's guide, laying out the different components that I mentioned, giving sub-guides to the different programming languages, Java, .NET, Python, and so on, so that you can have sort of a quick hello world, and obviously links to following up within the maze of OpenTelemetry relevant locations. So essentially, if you have any feedback on the guide or on the talk or anything else, feel free to reach out to me here at the conference or at Horovits on Twitter. I now joined the Metaverse, Fediverse, so you can find me there as well. And very importantly, remember that this is an open source project. So go ahead, and if you have something to contribute to impact, opening issues, commenting, even contributing some code, to make sure that this really answers our needs and becoming a de facto standard. So I'm Dotan Horovits, and thank you very much for listening.
Yourself open, get funky.